Ladies and gentlemen, it's my great pleasure to introduce our next speaker to you all today, who's going to give us some invaluable insights on the whole world of SRE and why it is the purest form of DevOps. Now, this is a subject we should all be deeply interested in. Our speaker is a very respected name in the DevOps galaxy who believes her core strengths are towards identifying opportunities to fuel business growth through technology and delivering the most optimum IT and automation solutions, earning huge credibility and trust of CXOs. She is currently serving as the Group Chief Technology Officer at IDC Technologies. Ladies and gentlemen, please put your hearts and souls together for a keynote speaker, Ms. Shivagami Gugan.
Good morning, everyone. I'm very happy to be here at the DevOps India Summit. My name is Shivagami Gugan. So I'm a DevOps, SRE, and cloud practical evangelist, and currently the group CTO for IDC Technologies. My passion is to actually make site reliability engineering work for the companies here in the Middle East. So just before today's topic is about SRE is the purest form of DevOps. Before we look into why is it so, I just want to start with a few things. So the first, of course, obviously, is digital transformation. I think it is the most Googled out word out there. It is the most hyped word, digital transformation. But what exactly is digital transformation? How does it tie it all to SRE, DevOps, and a lot of things that we hear about, right? So digital transformation is all about crossing the digital chasm. It's about the companies that do not adopt digital transformation will be left behind. They'll go bust. The life cycle of companies have really reduced, and the companies that really do adopt digital transformation, they have this hockey stick, exponential growth. We've heard of all of this, right? But what exactly do we do? I mean, how do we actually do this transformation? That's the whole point. How do we do it, right? So digital transformation, again, in 2012 is the year, which is quite significant, and most of you may know about this. So this is the year where Kodak declared bankruptcy. And this is the same year where, a couple of college geeks sold Instagram to Facebook for $1 billion. So what is it that these people did it differently? Kodak, you're more than a century old company. And then, of course, we have this, the success on the digital side with the digital companies. Now, these stories and such stories we keep hearing, and it's there and it's being reiterated so many times. But how do we get there is something that I've always faced a lack of information, right? And today we'll try to help and look into, how is it that we will get there? Digital transformation is a journey, everybody understands it, and it is a journey which is kind of intertwined, and there are a lot of companies now adopting digital transformation. So there are a lot of people who are doing, agile transformation, who are doing DevOps, who are doing site reliability engineering. So it's understood, these are all very intertwined. So what we're going to look at is the key manifestations of digital transformation. So how do you know that you're in the right path of digital transformation, right? And I look at it from 4 different areas, 4 different tenets. So the first thing is, if your employees, your staff are feeling very motivated, you've had all of them, aligned to your vision of, taking the organization to the next level. If you have given this very empowered environment to the employees and they feel very happy and they are doing things that are actually creating your products and your services that are, faster, cheaper, safer, more secure, then you know that you are in the right path. Now, the second thing is, of course, there's so much of emphasis on customer, and we all know about it. It's about providing this omni-channel experience to the customer to make them feel completely, frictionless. They come back to you, to your product and to your service. And you have this unique selling point, right, which has earned their trust. So we are talking about just moving beyond engagement to trust. But again, how do we get there? It's about optimizing our operations, making it more cost efficient so that we can do things faster. We can beat the competition. We can reduce the time to market, reduce our lead cycle times, etc., etc. And we transform our product and our services itself. So if we can make a positive impact on these four areas, then possibly we are in the right track for digital transformation. So this positive impact, if we just continue with that, right, time to market has to be faster. It needs to reduce. This is a very key metric that you would have seen for digital transformation. Business satisfaction going up because of a number of things that we're doing right. So, our defect rates have gone down, our services have become more reliable, efficiencies have improved, which means, whatever was the bill earlier, we are now, 20%, 30% lesser, cheaper than that. So these are the things, right? Now, how do we do it? And, I'm just going to list a few things out here. It doesn't really mean that this is a very exhaustive list. But if we do a few of these things, I've seen that the organization starts moving in the path of transformation. So the first thing is, of course, getting the strategy right. So here it's not about, there are a lot of people who talk about, we want all the nines in the world for reliability. It's very similar. I want transformation to be done every nook and corner of the organization. This doesn't happen. So we have to understand the organization characteristics. We should know where we are. We should select the target areas, and we should actually specifically look at how do we transform target areas, and then once it happens, it's going to catch fire and it's going to spread across the organization. So it's very key that we actually find out what are our target areas, right? The second one is, of course, we should come up with our strategies, and this strategy should fit the organization characteristics. It's not about Amazon or Netflix or Google firing up 3,000 containers a second. We are talking about our organization. Our organizations are built on legacy. We know about the characteristics of our organization. We need to come up with feasible strategies that will make a positive impact and make meaning for our organization. Generally, it has seen that if we take a agile delivery approach, it has helped. If we move from a very project-oriented mindset to a product approach, it helps. This means that people who create the project, who kind of create the service, create the product, they own it, they run it, and they operate it. Yeah, this is the key tenet here. Because previously, what was happening is you disband the project team, and the project team hardly cares, right? They are more into their metrics were very different. Do I meet the deadline? Yes. Have I met the budget? And they go away. How good have they built? It's the life cycle of the product starts only after it has gone live, and that is where you have the biggest life cycle, and hence it is very important that whoever builds it really runs it and operates it. It's a very key change, and if this is not happening, then possibly we will not have a very good transformation. This is something that we will have to make it happen. One of the key tenets. And the other thing is that we have this very loosely coupled thinking, loosely coupled thinking mindset, and we apply it across what we do. So if, for example, having an agile delivery mindset is also about the same thing. It's about small gradual change, bringing it right up to the architecture. How do we build microservices? Bringing it to the infrastructure side. How do we build the loosely coupled, immutable architecture, have containers, have a very service-oriented approach. All of this is the concept is the same, is to have this very small gradual changes, having a very minimal viable product mindset in our thinking, right? So this is key. Now, one of the again key manifestation is to empower our team, is to make them feel responsible for what they are, what they are creating. It's a big mindset change, not just for the people, because they've been used to looking out for decisions, looking out for guidance and help from the leadership. So it is a change both ways, right? For the employees and for the leaders. For the leaders, it's a complete mindset change, and it is about really making it happen. It's not about saying that that, I am a servant leader, I understand empowerment, but really, stepping in whenever a decision is required. So just getting the teams to wean off from the leadership, and the leadership giving this psychological safety, giving this ecosystem where people can fail. It would be still a very blameless environment. If people fail, they get up from, because it's a fail safe environment, they take the learnings and they move on, right? This means that we have to build a very talented resource base or a talent base. And here, when we talk about talent, the talent is not about just the technology talent, right? We are not talking immediately about, bring in cloud architects, bring in, people who know automation. Again, we see all of this, right? Configuration, chef, Ansible experts, we see DevOps engineers. Now, all of this is required, but we also are talking about our staff who have been with the company for so many years. So the people who have the mindset of getting upskilled, we need to empower them, we need to train them, we need to, the people who have the mindset of unlearning and learning are our talent base, right? So we have to have this healthy mix of people from outside who have done it, who have been in cloud born probably organizations, and mix them very healthily with the organizations that have legacy, that are not cloud born. And building this very healthy talent base is one of the key functions of the leadership. But once you build this talent base, and once you set them on the journey, we'll have to make sure that they're very self-regulated and completely empowered, right? And we will look at some of the ways of making this happen today. But this is a key concept that people have to understand. And it's a big leadership change. Now, DevOps, again, it's a culture and it's a mindset. It is not about tools. You must have heard a lot about it, right? But the point here is it is to break the silos and bring everybody together, bring the developers together with the operational guys, bring the testers, all of them together, and make sure that they learn from each other. So in this new culture, if you're talking about an operational person in this autonomous team, having a very cross-functional group of people, these people will help each other. And at one point of time, when the transformation keeps progressing well, you see that the operational guy, the development software engineer, almost, there's so much of an infusion of knowledge that has happened from both sides, that they become so good at, overall the team dynamics changes, right? And then testers and developers, they, test automation is about adopting the same kind of programming. They work very closely with what the programming language of the software is being developed. So testers, developers, the operational team, one of the key tenets is to ensure that the operational team does 50% of project work. Similarly, your software engineers have pages and they do, a lot more of operational work, right? They manage incidents, they get into incident resolution. So at one stage, there is this very healthy culture that sets into these autonomous self-regulated teams. And that's when you know that, yeah, you are moving in the right direction. You do not address people with names like, operational team, or, he's a software engineer, or he's a tester, because they almost become interchangeable. We also spoke about, building this fail-safe. I cannot emphasize enough of this. It should be faster feedback loops, fail fast kind of an ecosystem. So we are talking about, sprints. We are talking about having show and tells with the business to ensure that, whatever we build is having this very fast feedback loop. And this helps in transformation. If we adopt a few of what we are talking about here, we can see that positive impact, and this positive impact happens on all the metrics that we spoke about earlier, right? Be it the time to market metric, or be it the automation metric, the efficiency metric. And another key principle is to ensure that we have a very automation first attitude, and we automate everything that is possible. So this automation is the linchpin of transformation. So it's not about development phase where, CI/CD automation is quite popular, right? Build the quality gates, ensure test automation is there, ensure that, you do your security testing, shift left, ensure it's a part of the CI/CD flow. All of this is good, and it's great that a lot of organizations are moving towards it. We are also talking about taking this automation right through the product lifecycle on the operational side, ensuring we bring in concepts like AI ops. And you would see this today. We will discuss about why it is not a very advanced concept. Right when we start the transformation journey, if we can, bring about closed loop remediations or auto healing, and ensure that this is the mindset that people have, and you would just see that magic happens all across through the product lifecycle. Deployment gets automated. You bring in concepts like, canary and feature flagging, and these are the things that would really bring in a lot of efficiencies to the entire life cycle of the product. We've also seen that cloud brings in a lot of jumpstart to your transformation process. Jumpstart from a point of view that, it's not just the, pay as you go model, the transients that comes with the cloud, but definitely the jumpstart also comes because there's a lot of cloud native services. For example, if you want to build data services, so you want to build AI ML services, and if we think about building every such service by ourselves on-prem, then we are not actually we are not capitalizing on what's happening outside, right? So it is very important that we keep our eyes and ears open to what's happening, what's out there, and get the good things and have a jump start. And security is almost becoming an imperative now in cloud native, with the public cloud service providers. I think they are addressing a lot of concerns that were there earlier in terms of security, geofencing, making sure data is there within your country. It's highly secure. It's so much so that if we have to implement all that is provided by such cloud service providers on-prem, it would take years and it would take a lot more money, right? And data is the new oil, it's the new currency. And when we're talking about getting insights out of this data and doing all of this ourselves, it is going to really, really be very expensive, and it's going to take a lot of time. Hence, when you talk about cloud adoption, it's not just the infrastructure bit, it's also the services bit, the function as a service or going serverless and using the native capabilities of what is provided outside. Okay, so that's the base. And then we will look at why is site reliability engineering the purest form of DevOps. And I mean, there could be a lot of different views on this, but hopefully the key takeaway from today's presentation hopefully will kind of demystify a little bit of this. Now, site reliability engineering, when you talk about site reliability engineering, you ask 10 people about what is SRE and you would get 20 different answers, right? Because nobody knows what exactly it is. I mean, there is, of course, the Google definition, but every company is not Google. We do not have 1,500, 2,000 SREs. But the concepts and the principles are so good that we want to adopt this into our organization. And how do we make it work? Now, when you look at SRE, it's not about renaming our operational team or sysadmin team and calling them SREs. That is an anti-pattern, right? It's not. It's about a lot of things, but it's not about all these things in isolation. It's some people think DevOps is about CI/CD implementation, right? And site reliability engineers, if they have to support the product lifecycle, then it is about they are like maybe it's a misnomer for DevOps engineers. So renaming ops team as SRE is as much as an anti-pattern as renaming your CI/CD engineers, if you had any, as SRE. So ideally, there is nothing like a CI/CD engineer. At one point of time, all your developers should have imbibed automation so much, it should have gone into the DNA. So there is nobody like a DevOps engineer, right? Because you've set it up and it starts running and people know about it, and they get used to only one way of dropping code into production, which is the automated way. So that is where we want to be. So SRE again is not about CI/CD automation, or it's not about taking becoming a glorified system admin in isolation. So what is site reliability engineering, right? So here again, site reliability engineers are the people, they are very big collaborators. They are technologists. They are highly technical people who understand a lot of across the life cycle. Yeah, they understand system design. They understand deployment strategies. They go and solve incidents quickly. They understand all the layers of your technology landscape, your networks. They understand operational, the OS. They, I mean, this is very difficult, right? We are talking about a superhuman here. So here, I think the most optimum definition for an SRE is the SREs are the people who enable and make things happen that would bring about all the things that we saw, right? So he or she is not a superhuman, but he is the person who would actually collaborate with the teams, that so that the teams become more and more self-sufficient. They get transformed into delivering faster, safer, and more efficient, understanding more of automation, and move towards a very transformed world, right? So they are like the change evangelists, and they earn the respect from everybody, right? From the product team to the development teams, the self-regulated autonomous teams. They earn the respect of all these teams by the work they do. So SREs break silos. They bring the development ops team, the product team, everybody together. They play in this continuum of the product lifecycle. So as you would see in the next slides, they sometimes they look at system engineering, sometimes they look at software development, sometimes they look at operational excellence. But the key goal for an SRE is they would actually bring this harmony between the application and its ecosystem. They would bring software engineering concepts into system engineering, and they would bring in system engineering concepts into software engineering, right? And it's all about delivering business value. It's all about keeping the end user in mind. It's about making changes in a positive manner to the business metrics, right? This is the whole concept of site reliability engineering. And it becomes more and more useful to have this kind of mindset, mainly because the whole world is completely changing. The way we look at software, the way we look at services, there's so much of distributedness that when we are consuming services, we do not really understand who is a provider of the service, right? So let alone having control over that service, but we have to consume it to have, like we spoke about, have that jump start and to actually meet our goals. And if that is the case, our systems have evolved so very complex. There's so much of transience with all this elasticity that we're talking about. There is no single instance that we can keep. We name our servers and we holding on to a service. We're moving away from that kind of a mindset, right? So there's nothing like named servers. We moved to virtual machines, which became like cattle. Now we are talking about moving into immutable infrastructure. We're talking about having containers, and there's nothing like replacing containers. And I mean, like nothing like promoting into a container, but rather just kill the container and replace it, right? So we're talking about a very different kind of a approach, and we have to navigate this complexity. We have to navigate the scale and the speed and and this complexity. So it is almost getting beyond the human ability to mentally map this. So this is, I think, one of the service graph of one of the organizations which is very, very mature, like Amazon or Netflix. And even if we are not as complex as these organizations, it is just the truth that we are moving towards a lot of service-oriented architecture, and our systems are becoming very messy and complex, right? So when we talk about SRE is not about the whole concept is, a pager rings at 3 a.m. and we go and we kind of work for the machines, right? But with an SRE, again, if we have implemented the site reliability engineering quite well in your organization, or we are in the process of implementing it and it's moving in the right direction, then you would see that this will happen lesser and lesser, which means what actually happens, the machines will still break down at 3 a.m. But you would see that there is the self-healing that has been built into the machine. There is auto scaling, probably. Previously, if the machines were failing because of capacity issues or resources running out, you would see that it would still fail, but there is so much of a fault tolerance that is built into the system that an SRE's life is about not waking up and coming into the company at 3 a.m., but rather the next day he looks into the logs and understands why it happened and then build further fault tolerance, right? So the difference is there's so much of alerting, there's so much of fault tolerance that is being baked into the system or into the service that it mitigates itself, and the life is much easier now for people, and they don't have to wake up at 3 a.m. So they come and look into the logs the next day. Okay, that's when we know that we are moving in the right direction and SRE is working. So this is very classical. It's available. It's from the DevOps Institute. So we can see that there is this SRE blueprint, and this is based on the books that we have read so extensively about site reliability engineering. So there are a few key principles that do not change, right? Break the silos, build automation, remove toil. The whole concept of having meaningful SLAs and making sure that whatever the customer perceives has been baked as an SLA. It's not what we feel. And then how do we actually translate this SLA into service level indicators so that we have alerts on our system at a service level indicator stage, right? So these are the key tenets, and these principles don't change. This is very the core of site reliability engineering, and the broad responsibilities, of course, is to make sure that we have operational excellence and to make sure that our systems are reliable. But the whole point here is reliability is not just, it's an end point, it's the end game of the service, and that cannot be just owned by the site reliability engineer. Unless we do a lot of things on the left, right, we will not be able to get the reliability that we're talking about in the operational side. Hence, we are looking at the site reliability engineer contributing to system design, influencing the architecture, making sure that something that is being designed by the product teams will work efficiently in the operational when it comes into operations, making sure that the systems interact in a very seamless manner. And again, we're talking about the new things here, ensuring that the principles of loosely coupledness is kept all through. So we build services that are independent. We bake in fault tolerance. We build auto scaling so that these services scale up and down based on peaks and troughs of our traffic. And all of this is possible. Fortunately, not very expensive technologies as well. And a little bit of effort from our side to adopt these technologies, and it's easily implementable, right? So if we look at the metrics, of course, the metrics, if we have to bring faster time to market and better quality, and then the key metrics are, of course, the reducing the lead times and improving the deployment frequencies. And these are the metrics, right? When we adopt site reliability engineering or the digital transformation metrics, probably we were dropping code once in 6 months or once a quarter. We want to move towards dropping it more frequently, maybe once a week or once a day, or even many times a day. Lead time to change is actually after the business has communicated about a change. There is a great idea that he has got. When is it that goes into production, right? So here again, by adopting a lot of things that we spoke about, having the ability to actually even reduce the lead time to a day, or even to within hours, because we're talking about when we have a very full-fledged CI/CD automated pipeline with a lot of quality gates that are built in, then every single commit can go and actually fall into prod, right, and cause this feature change or the functional enhancement. So lead time to change having a very good impact on that. Once we are actually making the changes, and even if there is an issue, the ability to roll back quicker, to move forward quicker, to restore quicker. So crashing our MTTD and MTTR, so that we build in resiliency in our service. And if a fault does occur, we are able to recover from that fault in a very, very speedy manner. And we reduce the change failure rates as well. So this is a very key metric that we will look at. So here, there are several implementation patterns. So we are going to talk about a few here. But the key tenet is, the SRE builds the speed and performance. And there is this, it's not at the cost of, it is going to cost us an arm and a leg. And we are very, very sensitive to, it needs to give the stability, but at reasonable, right costs, right? So it's a very cost-effective thinking that the SRE has to bring about. So here I will just give an example. So in one of the organizations where we were doing this digital transformation, there was this huge amount of data that had to be transferred from on-prem to cloud. So they had embarked on a data transformation journey. And there was this, I think 4 to 5 petabytes of data that was getting transferred. And of course, when you're adopting cloud, all the good things that we come to know, pay as you go, and it's the scalability and all of that, which is really right, which is good. But when you have an SRE mindset, and in this particular use case, actually there was, when the SRE looked into the system design, he kind of suggested some changes, and that was mainly because the real-time streaming of data onto the cloud would have meant that we had to actually increase the bandwidth of the direct connect, or the express route, and that would have cost a lot of money to the organization, right? So finally the design was changed, because from an operational point of view, from an executing it from an operations point of view, it was much better to keep the real-time streaming of data on-prem, and then of course use the cloud for the rest of it, right? Which is for the batch and the micro batch and all the encryption of it, and ensuring that the data at rest and data at in motion. So the whole point is the SRE's intervention here saved a good amount of the cost, whilst it help us achieve the goal, and ensuring that there is speed, performance, and stability, right? So this is what we are talking about. And the site reliability engineers are they are very huge collaborators. We've been talking about how their role changes and they wear multiple hats. They are the people who will enable automation on the development side, which means they sit alongside the engineers and make things happen. They take the platform and product tools that are there and help the engineers understand and adopt these technologies, right? And like we spoke about, an organization which has been running for 10, 20 years, you have already a lot of very bright software engineers who understand the domain quite well. For them, probably, the CI/CD or the DevOps tool sets, these may be something that that they're not aware of. So an SRE becomes the enabler in making them understand how they go towards self-service, and they automate their entire product life cycle, right? So that's why a core competency for the SRE is, on one side, of course, the technical expertise and this knowledge and the breadth of knowledge across the life cycle, but for sure it is also the collaboration and the attitude to help people and to have this great mindset of and the patience to make things happen by helping others, right? We are also talking about the SREs to be constantly looking out at what's happening in the industry. So they are great learners. They have the ability to bring in what's really happening good outside into the organization and ensuring that it spreads out and gives this positive outcomes to the organization. So these are the other side of the SRE, because sometimes we understand SREs being very, very technical people, but the soft skills is also as important as their technology acumen. Now, again, this is not very prescriptive, but usually when you adopt a digital transformation journey, what do we see? We see people. We have to first understand what the organization is, because each organization is different. And this understanding of organization is not a very internal thing. It's not an IT thing. It's about understanding what your customer expectations are and to build our goals in line and in alignment with the customer, right? So we have to know the size, the type of the organization, the teams, how is the current structure of the teams, how is the leadership, and of course there are a large number of consultants and consulting companies who come and do this. The point here is every organization that is undergoing digital transformation should understand the DNA and the concepts, and they should understand what, even if you're using the services of a consultant, what is it that they're trying to do, right? So this is a very standard process. Probably, we already know that there are lots of maturity models out there for SRE, for DevOps. Are you flying? Are you running? Are you walking? And this is based on a number of parameters, questions asked to the people, a number of doing audits on what kind of toolings and technology and automation, where are we? If we have monoliths, how do we move these monoliths into microservices? All of this will contribute to understanding where the baseline is. And on the SRE side, again, are we having SLAs? If we have SLAs, are they meaningful? Because most of the organizations, they are ITSM-based companies, they have SLA, but how does this SLA translate into that single alert? And how are we actually ensuring that, finally we have alerts on SLIs, and these alerts are again tied back to somebody who is responsible, who can actually very quickly respond to once a threat is seen to an SLI, because a threat to an SLI is a threat to an SLA, right? And all the good things around rollbacks and immutability, graceful degradation, all of that, and how do we actually look at your landscape from a point of view of reliability and resilience. Now, there are several ways. I've just picked a couple of ways from Gartner here. So one is actually to look at, this you would know, right? If somebody, there are systems of record and differentiation and innovation in organization. So you would put all your customer-facing applications here, a system of innovation where you want real fast change. The point we spoke about, that the lead time being even up to 1 day, right? Because your competition landscape is very huge, and you want to keep up to the pace of whatever is happening in the market. So that is where you may want to really adopt a lot of changes and bring in that complete ecosystem of building everything as per the new technologies, right? So microservices, auto scaling through to containers, building in fault tolerance. But probably for systems of record, I'm talking about some ERP system where maybe, the changes are once in 6 months, and they're quite happy with it, with what's going on. So there's no point in enforcing this 100% agile, 100% transformation onto areas that is not going to produce the required business outcomes. It's not required to produce the business outcomes. The other way that you could look at is actually having a plot of your service graph. So you're looking at, the high intense red versus amber versus green. So where is it that you have a very high impact of incidents, and the incidents are also higher? The business is getting really impacted because it's a crown jewel application, or it's a tier 1 application. So this is something that you may want to do. This whole thing is we are talking about selecting the right target areas, right? The other model we could look at is what we call the time model. So tolerate, innovate, migrate, eliminate. We put the applications, we go through the application landscape, and based on the business value each of the application is yielding vis-a-vis the technology obsolescence. If the technology is also good, the business value is also good, that's the candidate where we would invest more. And the technology obsolescence is poor, but the business value is high. These are the candidates where we want to probably re-engineer. We again look at it really ties into cloud migration strategies, right? So if there's a lot of technology debt, there is already things creaking out there from a technology obsolescence point of view. Instead of pumping in a lot of money there, we will look at how do we re-platform it. And when we talk about re-platforming it, how do we really take it to the cloud and build it in cloud native technologies, right? So all of these are really intertwined, and we have to look at it from a point of view that makes sense for us, and then embark on these strategies. Not to emphasize more about all of this is about culture. There could be a frozen middle, so there may be some middle management who is not actually agreeing to what's happening here. And most of the times the ignorance of what we are doing and the fear is what would actually result in resistance, or result in people not actually moving along in the journey. And hence there are we're not going to talk about the entire change management piece here, right? But all the good things that you people know of, which is top down. There's a lot of top down engagement that is required. There is a lot of communication that is required. There is this, if there are good stories that are coming out of this transformation, then the way we actually spread the good news, get the business to spread the good news from one business to another business. There is a good impact that's happened on this product. How do we really make it happen on another product? All of this is really very important when we are doing this transformation. So we have the established phase where we actually get the blueprint for the site reliability engineering transformation, based on the maturity analysis, etc. Then we operationalize it. We build governance through, through the platform team. I'll talk about the platform team, and then we move more and more towards maturity. So please remember, the vision is key. Having a very focused, feasible vision is very, very important. Building the culture change, building the changes to the leadership, having an approach which is which is understood and which is very seamlessly accepted by the organization. That's key. And then the technologies and tools, and that's the easy part. Upskilling our existing people, reskilling them, that is also very, very, very key. Right now, this is it's a possible implementation. So you people are, I'm sure, very aware, already aware of this safe, agile, value stream mapping. All of this is important, right? Because this is the blueprint. So look into how is it based on. We could use domain-based design. We could look at business units. How do we really translate them into value streams, so that the key principle here is every value stream becomes very independent. They do not have interdependencies. It is a bit difficult, but once we get it right, it becomes much better, so that we do not have these interconnects and entanglement between the value streams, right? But it's not very easy. Again, an example that I give is, if you have your web and mobile and your customer-facing value stream, for sure they will have connects into your CRM, or your payment gateway, for example, and the payment gateway may be much more aligned towards your finance value stream. So there will definitely be some kind of connections, and that's where we will look at dependencies between the value streams. But as much as possible, one of the key considerations when you're building a value stream is to ensure that they are quite independent. And then once we have these agile release trains, how do we build autonomous teams? We spoke about autonomous teams quite a bit here. How do we place our SREs to actually make a positive impact on that product team, right? Now, to start with, we will have SREs actually taking care of products or services, but within that business unit. But it is not a hard, fast rule. Once we mature, we can also, rotate the SREs. We can have it is highly suggested that as we start, we build communities of practice for the SRE, just like you would build communities of practice for your product owners and your technical product managers, etc. Now, the SREs, their umbilical cord is actually towards the SRE product and platform team. Now, having a product and a platform approach is very important to build, to bring in consistency, to remove fragmentation, right? So they take all the good concepts, the standards, the processes, tools from the product team, and they actually make it happen into the ARTs. This is a proven model where we have seen it works very quickly. It doesn't take, for example, months or years to do the transformation, but it's really very quick. And there is a sense of belonging that comes up quickly within the autonomous team towards the goals that are really understood by everybody, right? So you have these common vision and common goals that are really understood by people. Okay, so this slides will be shared to you all, but primarily this is a list of what are the things that an SRE will do. So being embedded into a release train, they drive automation, they bring in, they look into system design, they will not become gatekeepers. So, here, when we are actually deploying the changes, one of the anti-patterns is to keep having them as gatekeepers, because there's no way that they can actually understand it's always true that the autonomous team will be more knowledgeable than a gatekeeper. Like then we are talking about like doing it in a cab model of what we have seen in ITIL, right? So here we are talking about embeddedness. We're talking about people being a part of the product lifecycle. They will influence the whole concept of error budget. We didn't speak about it, but one of the key principles of SRE is to ensure that error budgets come out of meaningful SLAs. And when we have the error budget, the person who actually brings about this balance between stability of the product and the functionality of the product is obviously a lot of people. It's an autonomous team, but the SRE is the key person there. The other thing is also to make sure that, if for example, we have worked out an error budget, and let's say that is, 42 minutes in a month. I'm just giving you an example. But if we were not able to use those 42 minutes in a month outage, it's very good, because we could use that outage for doing a lot of good things, for doing innovation, for ensuring that, trying out that ML algorithm, which we were not able to use, right? But what is very, very essential to have is to ensure that we fail back, we roll back and we fail fast in case, these experiments that we do fail. But having a good outage window, which comes out of error budget, is really good. And an SRE is key instrumental in making sure that, error budgets are implemented in spirit. And if we get the SLAs right and the error budgets right, and if we ensure that the SRE looks into the product design, builds strategies and automation for CI/CD, for deployment, for infrastructure as code, builds closed loop remediations in operations. I know it is a lot of work, and it's not going to happen in one or whatever days or weeks. But if a focus is there across the life cycle to ensure all of these things happen, then you are doing the right SRE and your organization is doing the right SRE. And hence I call upon again to say that, site reliability engineering is a SRE is actually the purest form of implementing the DevOps culture. It is the purest form of realizing the DevOps culture to bring about, this co-creation of the product from by taking everybody together, be it the operational people who were taking care of operations in the development team. And these people, the SREs, are the glue who makes it happen. So some of the few things here. So they participate in the continuous integration process by ensuring that we build automation here, deployment to staging, things like, ensuring that we do feature flagging, A/B testing, blue-green testing, canary, whatever. So the deployment strategies, ensuring that we have automation of functional tests, of non-functional tests, ensuring that the security testing happens as part of the pipeline, ensuring that there is a continuous deployment. When we deploy to prod, ensuring that, the right kind of monitoring. I think I've not emphasized about observability. So here, when we talk about automation we talk about automation. Automation is about the development and the deployment processes, and also building right kind of observability and monitoring into the entire process, right? So observability here has a very key tenet in the development phase, because observability is about building the capability of distributed tracing right when you code. So observability cannot be inherited later, right? The whole concept of extending synthetic user monitoring and real user monitoring into the observability space, which is building the right kind of telemetry, having the right kind of traces, logs, events that come out of the logs, ensuring that the right metrics come out of it, so the whole concept called MELT, so metrics, events, logs, and traces, ensuring that this happens within the product across the life cycle is again one of the main key responsibilities of SRE. So observability, automation, observability, and operational excellence, all the three major areas is actually a focus of the SRE. So this is what we're talking about, ensuring that your build is right. Here we even go up to there is automation so that code coverage, unit test coverage, cyclo complexity is not introduced in the code, ensuring that we have security testing done, all of this. So we're getting into a lot of details here, and we are talking about how the SRE will enable this. So the development teams or the product teams will do this, but ensuring that it is done in the right manner and helping the development teams, helping the product teams achieve this is an SRE's responsibility. Here, we're talking about observability. We spoke about observability just a minute back, ensuring that because of the transients, because of the topology keeps changing, ensuring that we have the right kind of observability built, ensuring that the breadcrumbs are put in the code, are baked into the code right when we actually create the software. So that is required during the run stage, making sure that we have the right kind of logs, translating into events, and ensuring that the alerts are put right in place. So this is just because it is so humongous, and we spoke about distributedness, we spoke about not hundreds but thousands of services. One of the suggestion, again, we are getting into the depths, but one of the suggestion again is to have system boundaries and to ensure that these system boundaries they help us in building the alerts. And then the alerts are tied to service level indicators or SLIs, right? This is one of the ways that the SRE can actually take it forward. Now, observability-driven development is key. We should build a culture so that no PR is accepted without ensuring that the piece of code has got test-driven development those days. Now we are talking about observability-driven development. Having a platform approach is very key, because platform, finally, one of the aim of an SRE is to make that particular product team completely self-sufficient, right? That's when the SRE can move from one product to another product, and you can have this cross-fertilization, utilization of ideas. But if that is the case, then ensuring that there is self-service built in, and because the whole, we are talking about hybrid cloud, multi-cloud, ensuring that we have the right kind of landing zones so that people do not go and build their own, and there's so much of wastage of effort because people are doing their own stuff. If they wanted a key management system or a vault, I have seen organizations where each team, they have smart engineers. They just go and build it. They just go and use some open source. They just do their own stuff, right? Ensuring all of this is tied together. Again, going back to that picture, the umbilical cord of the SREs is all tied to the platform team. This is a very good model to implement. And then I'm just talking very, very, very light touch about AI ops and chaos engineering. Here, AI ops is about, because the logs, the kind of data, the structured, unstructured data, there's so much of data that is coming into the operational space. It almost becomes impossible for the human mind to actually look into what's happening, right? So AI ops helps you into identifying anomaly detection, into looking at if there is a change that has happened, and if the business outcomes are impacted because of this change, automatically building rollbacks, ensuring that the first call resolution happens through intelligent routing, ensuring predicting even if an SLA will fail, because deep learning algorithms can study to the level of if a product, if there are based on a chain of events, it can even predict that there will be an outage, for example. So AI ops is a great way that we can start building more intelligence, and it helps making the SRE's life easier. That's it. So the whole concept is, when we go into from a diagnostic to predictive and prescriptive, we keep crashing the MTTR, right? So the traditional way, probably most of us are either in traditional or descriptive, right? Because of course the alert has come, but even if the alert has come, there is an MTTR, right? There is a mean time to recover, even if there's an automated alert. But the very good stage to be is that even before an incident is going to occur, we have this predictability built in, and these things can come from AI ops. And it's not an advanced concept. It is a concept that you can adopt right when you start your SRE journey. Chaos engineering is the same. Chaos engineering, again, the point is that it's a very advanced, and it's a myth. It's a myth. Chaos engineering is about starting small, and chaos engineering is an essential need. We need to identify what are the vulnerabilities, how can it withstand turbulent conditions. We have a lot of information on chaos engineering, and it's not about introducing chaos from outside. It's not chaotic. It's about identifying in a distributed environment, where are your weaknesses? How do we really build more resilience and more fault tolerance, and more methods of, even if a failure happens, how does it gracefully degrade? That is what is chaos engineering, right? And the whole concept of SRE is actually removing silos, yeah. And so there's just a very simple comparison. So previous ITSM has given us all the basics, right? And when the problem management process, the incident management process, the whole concept of change and how these are all perfect. SLAs also came from ITSM, right? We had SLA, we had underpinning contracts and OLCs, if people remember. All of this is taken into the next level, and the key difference is the self-regulation, the autonomous nature, right? So here, we can't have a cab who will decide on, similar to, you can't have an SRE who will decide on if the change can go live, because the best people who will talk about if a change can go live is that cross-functional team. So that is the key difference. And of course, like I spoke about, the slide is available for you, but these are some of the principles that we can use for execution. So if you are hiring from both fronts, from operations and from development, ensure that both of, like the developer, if you're hiring a developer to become an SRE, ensure that he spends 50% of the time in ops. Similarly, operation people spend more time in projects. So cap the operational load at 50%, ensure that automation is key, bring in people who have this cloud-born experience, and then intermingle them with your team. Make sure that it is self-regulated, even if the leadership knows the answers, to some extent, if you can step back and see how the team behaves and how they will learn from that failure. So these are a few things that we have to do. And I'm just going to finish it off by saying that SREs at an application level, they will actually look into the component, the design. I mean, you may have already seen Google had published about non-abstract large-scale design, NALSD, and this one is a key concept where we are talking about the SRE should know about solid design patterns and system design principles, right? So that's when they can influence application level. Of course, on the system engineering level, we spoke about observability. We spoke about how do you build good deployment strategies? How do we automate? All of that is again at the system level. And at an enterprise level, this is this community of practice. You could call it center of excellence, but it is this group of people who would make sure that we bring in what's happening outside, from the outside world, bring in all the new concepts, new technologies into the organization, and make sure that it spreads out from what we saw as a possible implementation of SRE. Just make sure that it spreads it out. So there is a need to have them at an enterprise level as well. So that is my experience of how we can make SRE work. Not just SRE work. SRE is the fundamental linchpin key capability for an organization who is very serious about digital transformation. And hence, how do you bring about digital transformation into your company through the entire SRE capability? That is what I had to tell. Thank you so much for having me. Shukran. Thank you. And if you have any questions, I'll be very happy to take it.